Put a blindfold on a pigeon, drive it 500 kilometers in a soundproof box on a winding route, and let it go in a forest it has never seen. Most of the time, it will be sitting on its home perch by dinner. Now cut the olfactory nerve, the one we use to smell coffee, and the same bird gets completely, hopelessly lost. Italian and German researchers proved this in a series of experiments that ran for decades. Smell is not even the strangest part of how a pigeon navigates. It might be the most normal one. So what else are these birds doing? Let's start with what a homing pigeon can actually do, because the numbers are absurd. Racing pigeons regularly fly distances of 1,800 kilometers in a single push. The average bird in a long race covers about 965 kilometers at roughly 97 kilometers per hour. The top racers clock closer to 160 kilometers per hour. They do all of this with no GPS, no map, no asking for directions, and no prior visit to the release site. You take a pigeon you raised in a loft in Belgium, drive it to Spain, open the basket, and the bird points itself home and goes. For a long time, people assumed pigeons had some kind of magic. Then biologists started running experiments, and the magic turned into a stack of senses we did not know birds had. The first big surprise came from smell. The Italian researcher Floriano Papi suggested in the 1970s that pigeons build a kind of odor map of their home region. Wind brings in volatile compounds from coastlines, forests, farms, and cities. Young pigeons growing up in a loft learn that this smell comes from the east, that one from the south, and so on. Take them somewhere new, and they sniff the air to figure out which direction they have been displaced. This sounded a little nutty when Papi first proposed it. Birds are not exactly famous for their noses, but the experiments were brutal and clear. Pigeons with their olfactory nerve severed, or with their nostrils plugged, or raised inside loft buildings where the wind was filtered, all showed the same result. They could no longer orient correctly when released from unfamiliar sights. Healthy controls flew straight home. The smell-impaired birds wandered. German labs replicated the work over and over. And by the early 2000s, the olfactory hypothesis had 4 decades of evidence behind it. A Tuscan study published around 2017 and 2018 finally pinned down what the birds are actually smelling. Researchers sampled air at release sites and at the home loft, and they found a fingerprint of volatile organic compounds. Dimethyl sulphide drifts in from oceans and wetlands. Terpenoids come from pine forests and certain crops. Aromatic compounds wash out of cities and farmland. The mix changes with geography, and pigeons read it the way you read street signs. If you have ever been moved by stories of animals doing impossible things, hit subscribe so you do not miss the next one. There is a lot more weird biology coming. So pigeons have a working chemical map of their region. That alone would be a remarkable discovery. But it does not explain everything. Birds released in fog, in headwinds, in unfamiliar continents still find north. Something more was going on, and for about 50 years biologists thought they had it figured out. The leading theory said pigeons had tiny crystals of magnetite, a magnetic iron mineral, packed into nerve cells in the upper beak. Press your finger against the top of a pigeon's beak, and you are touching what scientists believed was a built-in compass needle. This was the textbook answer for an entire generation of ornithology students. It was elegant. Iron is magnetic. Pigeons have iron deposits in their beaks. Pigeons can sense magnetic fields. Case closed. Then in 2012, a team using more careful imaging took a fresh look at those beak cells. The iron was real. The cells were real. But the cells turned out to be a type of immune cell called a macrophage, which scoops up iron as part of normal recycling in the body. They had nothing to do with sensing magnetic fields. The compass everyone had been studying for half a century did not exist. That was a hard moment for the field. The beak theory was disproved, and nobody had a good replacement. Pigeons clearly do sense the magnetic field. They reorient when you strap small magnets to their heads. They get confused near power lines and during solar storms. The compass was there. We just had no idea where. The answer arrived in a 2025 paper in the journal Science, and it is the kind of finding that makes you laugh, because the compass had been hiding in plain sight the whole time. The researchers were looking at the inner ear, the same organ that handles balance and hearing. Inside the semicircular canals, which are the curved tubes that let you know when your head tilts, they found something unexpected. The hair cells in pigeons have an extra set of voltage-sensing ion channels that birds in other groups do not have. When the bird moves through the Earth's magnetic field, these channels respond to tiny electrical signals induced by the motion, and the brain gets a constant readout of direction. Think about what that means. Pigeons feel the magnetic field with the same organ they use to keep their balance. Every time the bird turns its head, every time it banks in flight, the inner ear is converting the planet's invisible field lines into a sense of which way is which. It is sensory fusion at a level we are only starting to appreciate, and it explains why pigeons can stay oriented even when their eyes are useless and their nose is plugged. So now we have two senses working together. Smell gives the bird a regional odor map, and the inner ear gives it a magnetic compass that runs in real time. That should be enough for a pigeon to find home. But there is a third sense, and it might be the most beautiful one. Back in the early 1970s, vision researchers discovered that pigeons are tetrachromats. You and I have 3 types of cone cells in our eyes, which is why we see red, green, and blue. Pigeons have 4. The extra cone type is tuned to ultraviolet light. The world a pigeon sees is not the world you and I see. Flowers we think of as plain yellow are striped and patterned in UV. Foliage looks different depending on the angle of the sun. The sky itself has gradients of polarized ultraviolet light that point toward the sun even when the sun is hidden behind clouds, and pigeons can read those gradients like a map. That is not a metaphor. The UV sky pattern is a real signal, and birds use it to keep a heading when the sun is invisible. Combine that with the magnetic inner ear and the olfactory map, and you start to understand how a pigeon released in a strange forest 500 kilometers from home can be back on its perch by dinner. The bird is using 3 independent navigation systems at once, cross-checking them against each other, and pointing itself home with the calm certainty of an instrument that was tuned by 10 million years of evolution. The pigeon you saw on a city sidewalk this morning, picking at a discarded fry, has all of this running in the background. It feels the magnetic field through its skull. It tastes the air for the chemistry of home. It sees ultraviolet patterns in the sky that you will never see. We tend to look at pigeons as a kind of urban background noise. Biologists who study them tend to walk away with a different feeling. There is a lot of universe these birds are reading that we walk through every day without noticing. For decades, the standard answer was that pigeons had a magnet in their beak. Then the magnet vanished, and for 13 years, nobody knew where the compass had gone. Then it turned up in the ear, of all places, packed into the same hair cells that handle balance. The story is not finished. Researchers are already asking whether other birds, and maybe other animals, have the same inner ear channels. There may be a whole class of magnetic senses hiding in vertebrate ears that nobody has thought to look for yet. If you want more stories like this on the channel, stick around. The animal kingdom keeps quietly outperforming everything we thought we knew.